Earth's inner core may have stopped and started spinning in the opposite direction. Come, let's understand the mystery of Earth's core in this video. Initially, let us understand the core in brief. The core of the Earth is a central region of our planet located beneath the Earth's mantle. The Earth's core is divided into two parts, the inner core and the outer core. The inner core is a solid, spherical region and is made mostly of iron and nickel, with some small amounts of other elements. The outer core is a fluid region that surrounds the inner core. It is also made mostly of iron and nickel, but because of high temperature and pressure, the outer core is in a liquid state. According to studies and research, the Earth's solid, hot, iron ball-like core has recently stopped rotating and has begun to spin in the opposite direction. Experts have some interesting theories on why this might be happening. Despite the fact that it sounds terrifying, let's not panic and learn more about the situation and what the experts take on this. According to the reports, the Earth's core, which is located around 5,000 kilometers below the surface, is a planet within a planet and can spin on its own while floating in the outer core's liquid metal. According to the studies, the inner core can be determined by comparing the minute variations in the seismic waves that earthquakes or nuclear explosions produce as they move through the planet's core. A recent study that was published in the journal Nature Geoscience examined seismic waves from recurrent earthquakes that occurred over the previous 6 decades in order to trace the inner core's movements. The authors of this study of China's Peking University declared that they discovered in their study that the inner core's rotation came to near halt before as well in the year 2009 and turned in an opposite direction after that. They further added, "We believe the inner core rotates relative to the Earth's surface back and forth like a swing. One cycle of the swing is about 7 decades. This indicates that the core rotates in a new direction every 35 years, having done so in the early 1970s. They also predicted that the next about phase would be in mid-2040s. Now let's understand why Earth's core moves in the opposite direction. Earth's core rotates in the opposite direction to the mantle due to difference in the physical properties such as temperature, pressure, and composition, and because of the processes that drive their motion such as the transfer of heat from the core to the mantle through convection. This creates a complex system of dynamics that result in the core rotating in the opposite direction to the mantle. The Earth's core plays a crucial role in the planet's structure and magnetic field. The inner core is believed to be the source of Earth's magnetic field, which is created by the motion of molten iron in the outer core. The core also helps regulate the Earth's temperature and is responsible for the generation of seismic waves, which are used to study the Earth's interior. What happens if the Earth's core stops its rotation or starts rotating in the opposite direction? Well, if the Earth's core were to suddenly start rotating in the opposite direction, it could likely have several complex and far-reaching impacts on the planet's dynamics and environment. However, this scenario has not been observed and is not well understood, so the exact effects are difficult to predict. But let us understand some potential impacts where we may observe changes in few aspects. The Earth's magnetic field is generated by the motion of molten iron in the outer core, and a change in the direction of rotation could alter the strength and direction of the magnetic field. This could potentially lead to significant changes in the Earth's climate, as the magnetic field protects the planet from harmful solar and cosmic radiation. Changes in the magnetic field could also impact the Earth's climate, potentially leading to the fluctuations in global temperatures and disruptions in weather patterns. The Earth's magnetic field helps to regulate the planet's climate by shielding it from harmful solar radiation, and a change in the magnetic field could allow more radiation to reach the surface. Earth's core plays a crucial role in maintaining stability of the planet, and a change in the direction of rotation could impact the Earth's tectonic and volcanic activity. This could potentially lead to earthquakes, volcanic eruptions, and other geological events which could have devastating impacts on human populations and the environment. The Earth's core also plays a role in regulating ocean currents, which play a crucial role role in the planet's climate and weather patterns. A change in the direction of rotation of the core could also alter ocean currents, potentially leading to significant changes in the Earth's climate. The researchers said this rotation roughly lines up with the changes in what is called the length of the day. Small variations in the exact time it takes Earth to rotate on its axis. The researchers said they felt there are physical ties between all the Earth layers, from the inner core to the surface. Even if there are currently no evidence to suggest that what the inner core does has many effects on people who live on the surface. A day was only around 22 hours long hundreds of millions of years ago instead of current 24 hours because the planet was spinning faster than it is now. The movement of the Earth's molten core is one of the most important of these. It is unclear how much the turbulence within the liquid interior of our planet affects the rotation of the entire planet. Observing the Earth's core is challenging, and researchers are still unable to determine how much it affects the planet's orbit. When compared to viewing the constellation change over the year and the stars rise and set during the night, this is entirely different. But don't worry too much about the passing of your days. A change in the direction of rotation of Earth's core would likely have far-reaching and potentially catastrophic impacts on the Earth's climate, geology, and environment. The difference is minimal and consistent with prior variations in the Earth's revolving speed. Changes in the rotation of our planet should therefore be very low on the list of things to be concerned about. Even though the days might never quite be the same length, you might never see the Earth as it is anymore. If you like this video, hit the like button and subscribe to our channel for more informative videos.